Hey everybody, welcome back to Jim's Garage. You know I love a VPN, especially mesh VPNs, and in this video we're going to be looking at Tailscale. Now before we get on to why Tailscale, let's have a quick refresher on what a VPN and a mesh VPN is and why you might want one. So if you're running your home lab, probably the best and most secure way to access your services, especially outside of your network, is through a VPN. This means that you can securely share those credentials with anyone you want to have access, safe in the knowledge that all of that data is going to be encrypted. Now, there's a couple of flavors of VPNs. You can have your kind of point-to-point, so things like a WireGuard connection, or a bit more of an old school sort of open VPN connection. But recently, there's a more popular kid on the block, and that is the notion of the mesh VPN. Now, there's nothing wrong with using point-to-point. I've been using it for years and I still do, but I also use a mesh VPN as well. The fundamental difference here is being that mesh. Much like you might have seen with a mesh Wi-Fi setup, whereby you have multiple different access points that all sort of connect to each other and feed off one another, the same principle is sort of true with a mesh VPN. So instead of that traditional sort of hub and spoke model, you now have a mesh network where you have complete control over all of the nodes within the network, and more granularly, you can actually set specific rules between those nodes. So you could have client 123, node 123, whatever you want to call it, and you could have specific rules between each of those clients. So it's not a one-size-shoe-fits-all, i.e. you're not just going to allow clients to access each other without any restrictions. You can put in granular rule sets for what you want, be it IP, protocol, anything you want. Now, I've covered mesh VPNs on this channel a few times before, most notably with things like Headscale, which is an open source implementation of Tailscale, and also NetBird, which is currently my mesh VPN solution. But you're probably thinking all of this sounds complicated. And that's kind of true. It's not necessarily complicated, but there are new things that you'll have to learn if you're coming from the more traditional point-to-point VPN. Now, that's where Tailscale comes in and excels. Now, they have a simplistic, and it's important to note the distinction between simplistic and simple. There's still a lot of technical stuff going under the hood, and you're not doing any of that security trade-off by using Tailscale over something self-hosted, other than Tailscale are going to know exactly your sort of external client IP address, but that's up to you whether you have those privacy concerns. The real beauty of Tailscale is that you can get this up and running within just a few minutes, as I'll demonstrate in this video. Now, traditionally, Tailscale, if you have sort of an open local network, you'll be able to take advantage of using Tailscale locally, i.e. you can connect VPNs within your LAN, but if you've got firewalls between VLANs, etc., it will have to reach out to what's known as a DERP server. Now, the good news is with Tailscale is even if you're using the DERP server and this server is hosted by Tailscale, i.e. you'll be routing your traffic through their network, the actual traffic that is sent is still end-to-end encrypted. So there's no way that Tailscale can have a look at the data inside that tunnel, and it gives you a convenient and performant way of actually connecting those devices. The quick way to fix that would be to put in firewall rules to let those nodes connect to each other, but you don't have to worry about that, it will still work without it. And as I'll show in this video later on, I was able to get over sort of 1 gigabit using their DERP server, which is really impressive. Some of the advantages of Tailscale as well is it's free up to a limited number of devices, and obviously they have a pro subscription if you would want to scale this up to a more enterprise-based solution. You can conveniently manage all of this stuff through a handy web interface that they provide for you, and it's as simple as going to their website and connecting to it. There's also handy mobile applications, so not only can you do this for VMs, physical devices, etc., you can also use it on your mobile phone. This is why Tailscale is probably the most commonly used mesh VPN solution, and let's now get into how we can set this up and be a part of that club. Now, before we head over to the Tailscale website and take a look at this prior to getting it set up, I have created a few virtual machines which I'll be adding to my Tailscale network. Now, you don't need to do this, but I've created the following virtual machines. You can see here that I have this test virtual machine 4, and that's assigned with a tag of 3, so on VLAN 3, and I've also created this test VM 5 here with tag 9. That's just so that I can put these onto different VLANs. There are no rules within my firewall to allow that communication because I want to demonstrate this using the DERP server. We'll also then put some firewall rules in place and hopefully get this communing intra-LAN, so hopefully much faster speeds. I'll also be showing you the mobile device, and so you can connect to that as well. Thus you could have virtual machines, physical machines, mobile devices, all connected to each other via that mesh VPN. So if you head over onto the Tailscale website, you're also going to need to create an account to use Tailscale. So as you can see on screen here, there's an example of what the mobile application looks like, and also the desktop application looks like this is in macOS, where you can see what it looks like in terms of the application in your system tray, how you'll connect through your user account, and the details it's going to show you. Obviously as well, being a mesh VPN, it's great because you can also use these devices as exit nodes. So if you had one of these nodes in a different country, you could basically create your own VPN and get around some of those geo-blocking restrictions. So how do we get started? Well, I've already mentioned we need to create an account. So I'm going to hop into a incognito session here and create a new account with a new email address. The quickest way to do that really is just to sign up with one of your existing identity providers. I'm going to use just my Gmail account for this, so I'm going to go through that process now. It's going to ask you why you want to use this, either business or personal. It's going to ask you to add your first device. I'm going to use a Windows device on another virtual machine. The two that I showed previously are Linux devices. So basically, you can either skip this or walk through it. So we can download the Tailscale for Windows. It's just going to take us to the binary page to download that. Once you've started the download process, if you'll notice here, it's actually waiting for that first device. So I'm going to copy this link. I'm going to hop into my Windows 11 virtual machine and we'll get the first client added. Now let's download Tailscale for Windows. That shouldn't take too long. Once it's downloaded, we can open that and get it installed. This should be pretty straightforward. We'll agree to the license. We'll accept this. And now that it's completed, you should see in the bottom tray now, we have this icon for Tailscale. Here it is, just down here. So what we need to do now is head down to the system tray. We need to right click on it, and then we need to authenticate, so log in. So if we click on that, we should be redirected to log in. Now what we need to do is obviously to sign in with the same account that we used previously. So after logging in, and you can hear my phone pinging doing the 2FA, we should be in a position now where we can connect. So the final stage then is to click on the connect button. We've now successfully logged in, and hopefully if we go back down here, you can see, yeah, now the Tailscale is connected and we can click for some additional options. Now if I hop back out of this virtual machine, it's actually taken me to the right page already, which is great. So even though I'm on a virtual machine, it's taken me to the next step in that login journey. Here you'll now see automatically that this Win11 machine, that's actually the name of the virtual machine itself, has been added to the network automatically. Now at this point we could obviously go through all of our devices. So we could add the Linux devices, that's the VM. We could add our Android mobile phone or iPad, whatever it is, even a Synology, which is great. So you'd simply need to repeat that process. Now I'll do the Linux one just as an example, and I'll also show Android, but it should be pretty straightforward. So I'm simply going to copy the recommended installation steps for this. So let's copy this script for the Linux. I'm going to start up both of these virtual machines that we're going to test on. Once those are booted up, I'm simply going to remote into the terminal and I'm going to run those scripts. So on screen here, you can see that I've remoted into that test VM4. So it should be as simple as just pasting this in here. We might actually need to run this as sudo. Let's find out. Note that seems to be running locally, which is great. I'll also paste it in here and run on this machine. And hopefully by the end of this, we should have the application installed. And yeah, it's asking us here to do a sudo tailscale up. Now, when we do that, it is going to ask us again for that installation journey. So let's try and do that now. So if we do a sudo tailscale up, it's going to ask us now to copy this URL here. And this part on the end is our unique code. So it knows that this login attempt is with our journey. So if I right click that, copy it, we can head over now to our browser. We'll paste this in and we'll get up and running. I've popped back into my VM, but you can do this on any machine. I'll open a new tab and keep that one there. So if I paste that in and I choose the same account as I did previously, if I hit connect, that's now successfully connected. So let's go back now and see what's happened in the VM. So now you see that the success line has been added, and now we successfully connected this virtual machine to the Tailscale network. So I'm going to do exactly the same thing for this other one over here, and then hopefully we'll be in a position where both of these are connected. So now that final one is connected here, and if we go back to our original tab up here, we should now have that Windows 11 machine, the VM4, and hopefully in a second VM5 will populate. I'm also now going to download on my Android phone the Tailscale application, and I'm going to add my phone to that. That's going to be exactly the same journey as previously shown. We'll download the application, we'll log in with our Google account in my case, and we'll then authenticate it within the application. Now I've added all of my devices. You can see here what I've ended up with. I've got the Google 6 Pro, which is my mobile phone. I've got the two Linux VMs, which you can see here, and it tells you what they're running. And then I've got that Windows 11 machine, which is actually this screen I'm recording on, not the one where my little face is. That's on a different machine. But now we're basically in a position whereby all of these devices have been seen and are connected. And you can see down here that our network looks lonely. And the free plan lets you build a Tailscale network with up to 3 users. Now, that's not 3 devices. My understanding is you can have as many devices as you want, but think of that as the accounts you log in. So my Gmail account that I've logged in, that's 1 user. So you could have 2 other people within this network, or you could have 2 other accounts that you own if you want to split your own network up that way. If you want more, you're going to have to pay for it. But I think it's a great offering for getting started and learning what mesh VPNs are all about. And then maybe if you want to take the brakes off and you don't want to pay, then you can set up something like Headscale, or you could set up something like NetBird and do all of this management yourself. But anyway, let's get on to some use cases and some testing. So here we are. I've pulled up the 2 virtual machines I used before. And if we do an IPA on these respective machines, we should be able to see the local IP addresses is pulled up. So if we look on here, you can see that I've got 3.101 on here and 9.107 over here. Now, within my OpenSense router, I do not have firewalls allowing traffics between these networks. So if I do a ping and I try to ping the 9.107, you can see that that data is being dropped, and conversely, if I do the same on the other machine, you can see that that data is also being dropped. Now, if we stop that, and then we actually have a look at the Tailscale IP address, and we try to ping those, you can actually handily see it in here as well, but if you're missing that, you can go back here and you'll see the IP addresses associated with it as well. So in this sense, let's do a ping, and let's do 100.105.42.72. You can see that over here, just this part here. Hopefully if we do that, we should get a request. Yeah, there we go. We can see that that's all being routed. And then if I do the same thing on the other machine, you can see that I'm also now reaching that machine. So this is a great way to demonstrate having a network that is segmented. I'm just doing this locally with VLANs, but this could be anything. This could be you're behind carrier grade NAT, for example. You can't do port forwarding, all of those sorts of things. Now what's interesting is because there are no rules between these on my local network, they can't reach each other. This is actually now being routed over the Tailscale network through their DERP servers. And you can probably see that because we're getting some latency here. Looks to be around sort of the 40 millisecond mark, which as anyone who's ever tinkered on their local network, typically you'll get less than 1 millisecond. So we've got a reasonable degree of confidence that our traffic is being routed over the internet. Again, remember, this is all end-to-end encrypted. So yes, you're using Tailscale. Yes, they can see my public IP address, but in terms of the data that's being sent, they have no idea. So let's now test that because there is actually a command you can run to see whether you're being routed locally or whether you're being routed through the Tailscale network. And so if we run the handy command tailscale net check, now the bit we want to look for, if we scroll up, is this line here at the top. the mapping varies by destination IP is true. Now, if we go over to the official documentation, you can see here that when it's set to true, the device's IP address and port numbers varies between DERP relay server. Basically, the DERP servers don't have the same ports and IP addresses available to them. That's because basically these are behind two different subnets, in my case 2 VLANs, and there isn't a clear way between the two nodes because there's a firewall in the way. So we're effectively behind what's called hard network address translation, and so the device is likely using a DERP relay server. If we change that to EasyNAT, like we say here, then Tailscale should be using direct connections between the nodes, i.e. it can connect to one another. Now, if we look in my OpenSense router at these two respective VLANs, well, I'll just show you 3. But here you can see on this VLAN 3, all it's allowed to do is connect to the internet. It can't connect to anything locally, and it can only connect to my DNS servers just so it has internet and it can pull down things like the Tailscale client. That's also mirrored on VLAN 9, so it can't go anywhere. This rule is actually disabled, but I'm basically going to create this rule now just for testing purposes on each of the respective VLANs. What this will do is then basically allow it to access anything on my network, i.e. it becomes a trusted or a management VLAN almost. I'm going to go here and I'm going to add a rule. I'm going to say, yes, pass everything. You've got access to everything. We'll put this one at the top here, and then I'll hit apply changes. Now, hopefully after a reconnect, if we go back over now to those two respective VMs, hopefully we won't use a DERP connection and we should be able to get direct connections. So what we're hoping for is that this value that we've got on this screen here changes from true to false. And if we look at that documentation again, we know that false, the device is likely to use a direct connection because it's behind EasyNAT. Now, you might be thinking, why do I want to do that? The main reason is performance. Because it's not being routed to the DERP servers, the performance should be better. Now, one important thing you will need to do actually is if you're using OpenSense, you'll actually need to create in the firewall rules a NAT outbound rule, which allows static ports to be set to yes. OpenSense by default doesn't allow things that change their ports dynamically, which is what happens with sessions within WireGuard and thus Tailscale. So with that said, we can now run the command again. So that net check, we'll do it on here as well. And with any luck, if we now scroll up, we'll see that mapping varies by destination IP equals false. Perfect. And we can also see that on this machine here, false. Remember, it was true. So now we have direct connections between these two nodes. Hopefully now, if we do a check, so let again do that ping. Now you can see, yeah, much better. We're getting less than a millisecond instead of the 40 milliseconds we had before. Let's just check that we're getting the same on the other side. Yep, we're getting sub 1 millisecond times on average. So now you can see that we've made this much more performant, and we're now routing traffic locally, albeit all that traffic is still encrypted, which is great. So for a bit of fun and additional testing, I'm going to install iPerf 3. I'll do that on both machines. For those of you who don't know, this is basically a network performance tool. Now that that's installed, we'll do a iPerf 3-S, and that will set this one up as a server. And so now if we do an iPerf 3 and then we do a -C and we tell it that the client to connect to is this one over here on the left, we should be able to get a speed test up and running. So if we now run and it's listing on the other one, that IP and port, here you can see it's connected, and yeah, we're getting what, 4 gigabits per second, so 400 odd megabytes per second. Awesome. That's really impressive, and you get to see the speed at which Tailscale can work. Obviously it's running the WireGuard protocol, which is baked into the kernel, so again, that's really helpful for speed and hardware offloading. If you want to test that quickly and see the difference between this one and the DERP server that's provided by Tailscale, we can also do that. To do that, I'm basically just going to drop the firewall rules that were in my OpenSense, and that should then force it back to using their DERP server. To do that, I've simply disabled the rules that we had previously, And now if we go back into this and hopefully if we run that again, I don't know whether it's going to have automatically failed over to the DERP server. Let's see what happens. Yep, it's connected. Doesn't look like the firewall rules kicked in yet. So now, full disclosure, I did have to actually tweak a few rules. I did have to reboot these machines. For some reason, it looked like the firewall rule wasn't immediately applying in OpenSense. But now I've remedied that. You can see that we were pinging the same machine. So we connected here to that port, which is this machine over here. And you could see that we were getting around sort of what? 10.6 megabits per second, so a stark contrast from what we were getting before, which was 4 gigabits per second. And if we do a network check, we know that it's gone back to that previous setup, and we can be confident that this is now routing that traffic through the DERP server, because there's no way that these nodes can connect to each other locally, because they're on different VLANs with specific firewall rules to block that communication. So now that we've set up some of the more complicated nodes on Linux, we've shown how we can improve performance by putting in firewall rules if they are on different VLANs to improve performance. But we can also now have a look through the user interface back on the Tailscale website, because there's a number of things on here that are really useful. So at the moment, basically what we've got is a network whereby every node on here, every machine in this case, can communicate with one another. Now you can, a bit like a firewall, you can break that up. And handily as well on each of these machines here, you could actually click those, you can set the name, you can disable expiry so it's always in. And then the important bit, and the bit that we want to get onto, is the root settings and the ACL, the access control tags. If we look at the users tab here, we'll be able to see all of the users that we've invited or are in an approval state. Obviously, if you want to invite people to your Tailscale network, they will show up here and you'll be able to see in terms of privileges what they can do. You can view their devices, you can edit their roles and the group membership, for example. In terms of access control, now this is where it gets really interesting. In terms of Tailscale, everything is done through these access control lists, and those are basically driven through this syntax here. Default, it's going to allow you to do everything. You can use handy tags to basically drop or amend what you want to do. So at the moment, ACLs allow all connections. Comment this section out if you want to define specific restrictions. And it gives some examples of what you might want to do here. So for instance, you might only want a certain source to be able to get to a certain destination. The best way to do this, the easiest way to do it, is to put people into groups and then use those tags. So we'll get onto that in a minute. And as we've seen, my virtual machine 4 and virtual machine 5 can talk to one another. We've demonstrated that extensively. So if we have a look at the documentation, there's some good examples over here on the right. So if we have a look at one here, rather simply, all we're looking at here is blocking IP addresses to IP addresses. This isn't the best way to do it, and we'll have a look at tags in a moment, but you can specify a source and a destination here. And I've basically commented out here, this is the default one, which allows everything. And in here, we can put the source and the destination. So at present, everything can connect to one another. If we now go over to here, we say that this one, test VM4, this one's the source. Let's copy that. And if we go from that one and paste it in, if we now get the other one, we get that one, and we paste it in here, we're now saying that that will be accepted, but by default on a firewall, everything else outside of that shouldn't be enabled. If we have a look at the preview changes, you can see what we've added here and commented out. We can now save that policy, that there's no errors, and hopefully if we now try and connect, it shouldn't allow us to do that. So with any luck, we should be able to ping from VM4 to VM5, but not the other way around. And here now you can see that this machine on the left can access and ping this one, but when this one tries to ping the other one, that connection is blocked. And that's, as a reminder, this little rule down here. This one accepts, and because there isn't an explicit accept rule here, this one is being denied. Now what's important is we can actually put some friendly tags in there to make this more machine readable. So what you can actually do is go onto here. If you see the example at the bottom, you can set some hosts up like this. So we could just call it VM4, give it a name and an IP address, and that would make it much more machine, human-friendly readable. And we could do things like this. We could say the source is a machine name, i.e. something you can remember. You don't have to remember an IP address. So one other final thing, now that we put some firewall rules in place, the routing is also another important feature of a mesh VPN. As I've mentioned before, the routing allows you to say where do you want your traffic to be routed. So for example, these three machines here, the VM4, 5 and the Windows 11, these are all virtual machines that are just over there to my right in my server rack. These are all local devices. But my mobile phone, for instance, isn't necessarily always at home. It's on my person. If I'm taking this out and about, I'll obviously be picking up a cellular IP address. And what's good is I could actually then use this Tailscale network to remote back into these machines. And conversely, if this machine was, or my phone was elsewhere, or in fact, forget this is a mobile phone, pretend is another virtual machine. It might even be in a data center somewhere, or it could be a friend's machine in a different country. We could actually route all of our traffic on this network or specific devices and use this one as an exit node. That would mean that we get the public IP address of that machine, and if you're trying to do things like circumvent geo IP blocks, you could do that. For instance, on this one, if we hit on the three dots here, we can actually go to the root settings of that machine. Now you'll see that if we try to do that, we actually need another configuration step. If you hover over this, you'll see that we needed to run this with the -- advertise exit node flag. Now, that's just as simple as going back and doing the Tailscale up and doing that. I'm not going to do that for these machines, but what I am going to do is hop onto my Android phone. I'm going to jump off my Wi-Fi, and I'm going to allow it to be an exit node. So now that I've set my mobile phone as an exit node, hopefully I should be able to click on these dots now and click edit route. It took a little while for that to be recognized, but now you can see that this is running as an exit node. So now we can go to these three dots and we can go to the edit route settings. And now we can select use this as an exit node. So we can click save. So now that's used, and you can see in the bottom right, that's now been updated. Now, to make use of that, I'm probably going to have to go back to the access control. And remember, we put this rule in here. So I'm actually going to delete that rule. And just for simplicity, I'm going to allow everything to access everything else. So putting that rule back in place that we had before, that should now allow everything to connect to that as an exit node. And because we've allowed it now to connect all those nodes, if we go in the bottom right here, we should be able to right click on that, click exit nodes, and then you can now see that I've got my Pixel 6 Pro as an exit node. So hopefully we can click having my Pixel 6 Pro, and that's connected to my cellular network. Now hopefully if I try and find out what my IP address is, it should give me the public IP address of my mobile ISP. Now doing that did actually boot me out of my RDP session, but if I go to the My IP tab and refresh that, you can see that it's picked up now the IP address of my mobile phone. That is not the IP address of my regular home-based internet provider. So excellent, we're now routing traffic through my mobile device, and obviously you could change this to be any of the devices on your network, and you could circumvent some of those geo IP blocks. So hopefully that was a useful demonstration of how you can set up Tailscale and some of the more basic advanced features, if that makes sense. There's a ton of documentation on there, and you can set up really granular specific things for your network setup, going through things like the access control lists, fine-tuning things like the network address translation, etc. But hopefully now you've got everything you need. You can invite users to your network, you can control traffic between devices, and ultimately you can have confidence in the security and privacy of those communications into your network to access some of your sensitive services. Let me know if this is something that you're going to use, how you're going to use it, etc. And if there are some other features of Tailscale that I might have missed or you want me to cover. Anyway, I hope you've liked this video. If you have, give it a thumbs up, hit that subscribe, and I'll see you on the next one. Take care, everybody.